Okay, welcome. So today we are going to talk about exponential equations. And we're going to show you how to solve them, and they're really easy. You just have to remember one of the properties of exponents that we talked about earlier in a previous video. So the idea of exponential equations is we're going to use the fact that since this function of the form a to the x is a one-to-one function, we only need to show that x1 is equal to x2, which in this case are going to be the exponents. So we just have to show that the two different exponents are equal to solve for this equation called an exponential equation. Okay, so we call these exponential equations. So all equations of this type where we've got an exponential here and an exponential here with an equal sign, then that's an exponential equation, and we're going to use this property to solve that. And so with that being said, we're going to do three examples, and the last example that I'm going to do, I'm going to do it two different ways. Okay, so let's do A first. So what we're looking for is we're looking for a common base. We want to get the same base. So realize that we have to have the same base in order for this to work. So what we need to do is we need somehow to get the same base here, okay? Now, if you notice, over on this side, we've got a 3 on the left, okay? So I'm keying in on this 3. Well, there's no multiple or power of 1/3 that's going to give me this. But if we notice, okay, if I have a 3 here, but I notice that what? This can be written as 3 cubed. So now I've got a 3 for a base here, and I've got a 1/3 for a base here. But I can also use another property of exponents that we've learned, that I can flip this, and I can write this as 3 to the negative x. Okay? So again, you're going to have to remember your properties of exponents, right? So I can write this. Now, look at this. I've got the same base here. And so now I can use this property that says, hey, if these two are equal, then guess what? Then the exponents must also be equal. Remember that? That's what we're using up here. Okay? So, in order to show that these two equations are equal, all we have to do is show that the two exponents are equal. And so I'm using the fact that since we're already starting with this assumption, right? We're starting with that these two are equal. And I want to find all of the x values that make this true. So that means if these are equal, then guess what? That also means that the exponents must be equal, which means negative x must equal 3, or x equals negative 3. And again, plug this back in. Okay? Plug this back in and verify that this is correct. Because if I put in negative 3 here, right? So let's say if I put 1/3 to the negative 3rd power, well, again, I'm going to use my rules of exponents, my properties of exponents, that this is the same as 3 to the 3rd power, which is equal to 81, and it works. Okay? So that's A. So A is solved. Okay, now what about B? Same thing. We're going to do the same thing. I need to get a common base here. So what I'm going to do is I'm going to rewrite 8 as a power of 2. So I'm going to rewrite, I can't rewrite 2 because it's prime. But I can rewrite 8 as 2 to the 3rd raised to the x minus 6 power. Now I'm going to use the property of exponents, one of the power rules. And so a power raised to a power, I multiply those powers together. So now I'm going to get 2 to the x plus 4 power is equal to 2 to the 3 times the quantity x minus 6. Don't forget the parentheses. Now I can use the property that I've talked about. Since I have the same base and they're equal, that means the exponents must also be equal. So now I get this equation. And so now I get to use the distributive property, combine like terms, and solve. So I get x plus 4 equals 3x minus 18. Okay? And if I subtract x from both sides, and I add 18 to both sides, what do I get? Oops. I get what? Negative 4x, right? I get negative 4x is equal to negative 14. Is that right? I just want to double check. So I get, oh, hold on. Nope, I made a mistake. I knew that didn't look right. I was looking at the wrong one. This is positive, so this gives me a 2x. I'm sorry. So I get 2x is equal to 14, negative 14. Just made another mistake. Okay, so again, the 3x minus x gives me a 2x, and then the 4 minus 18 gives me a minus 14, and guess what? I get x equals what? I get x equals negative 7. Now, again, double check. Plug negative 7 back into here and make sure you get the same answer. So if I plug in negative 7 here, I get 2 to the third. Okay? Which gives me 8. If I plug in negative 7 over here, oh, hold on a second. Something's not right. Why am I not? Let's see, 3. Maybe I'm just overthinking this. So 3x minus 18. So x plus 4 equals 3x minus 18. That's right. And then I subtract x from both sides. That gives me 2x. Oh, that's where I made my mistake. I knew something wasn't right. See? That's why you should check your answer, because I wasn't getting the same answer on both sides. And I forgot I added 18 to both sides. That's where I made a mistake. So this is 22. Which gives me x is equal to 11. 11 is my answer. Now let's double check. So 11, I get 11 and 4, which gives me 15. I get 2 to the 15th over here. And here I get 8 to the what? 11 minus 6, which is 5. But I can rewrite this as 2 to the third, which is going to be 3 times what? 3 times 5, which is 15. So I get 2 to the 15th on both sides, and it works. So x equals 11, okay? Now, let's do C. I'm going to do it 2 ways. So again, I'm going to erase after I'm done, but again, you're going to want to make sure you're taking notes. So the first way I'm going to do this is I'm going to write this as okay, so I'm going to use the property of exponents to rewrite that as a third root, cube root. And so what I'm going to do is I'm going to what do I want to do here? I'm going to write this as something to the third power, okay, which is going to be 3 to the third power, right? And so where I'm going with this is I want to be able to use the property of exponents with rational exponents to be able to cancel things out. Because I could go ahead and multiply or cube both sides, but that's going to give me a big number that I'm not going to want to deal with. Okay? So what we're going to do is we're going to write this as this way. We're going to write this, instead of squaring, I'm going to rewrite this because we can do this, right? So again, I'm going to write this as this way. Oops, yeah. Like that. Okay. Now, that's going to be a lot easier to deal with because I know I can write 81 as 3 to the 4th power. Okay? So what I can do is I can write this as right? I can do that, and I can use the property of exponents, and I know that, hey, since I've got a 4th power, that means this must be equal to this, right? But, okay, now, if I do that, I gotta be careful. Oh, wait a minute, hold on a second. Yeah, that's right. Right? But if I'm going to write it with the 4th power, gotta be careful because one way of doing this, well, here, a better way to see it, okay? Because if I do the cube root, if I do it this way, I'm going to make a mistake, or there's a chance I can make a mistake, because what I'm going to do is I could go from here and I could say, this is equal to 3. But you gotta be careful, because I'm missing information. So let's go back to this. And what I'm going to do is what can we do to both sides to get rid of that 4, okay? Different than what we did over here. So with these, it worked fine. Okay? But with this one, it's not going to work as easy because we've got this 4th power. Okay? So how are we going to do this? Well, let's go back to what we know from the square root principle. So we could take the root principle and we could take the 4th root of both sides. But remember, since it's an even root, we have to add a plus minus, and that's what we were missing before. So, if I take the square root of the 4th root of both sides, I get the cube root of x is equal to plus or minus the 4th root of 81, which equals plus or minus 3. Okay, so that's the piece that you could have missed by doing it the same way that we did it here, okay? And then, oh, let me make sure, yep. And then what we can do now is we're going to cube both sides. And if we cube both sides, now we're okay because then we get plus or minus the cube, 3 cubed, which is 27. And so we get x equals plus or minus 27. Okay? So that's one way of doing it. Now the other way, an alternative way to do it, is to use the power rule. So let's go back here. And so now what I can do is let's use the power rule and let's raise both sides to a power of 3. Okay, now, at first glance, you're thinking, well, if I'm going to cube 81, I'm going to have to get my calculator. But hold your horses. Don't just jump to the calculator because it's available and because you think this is going to be a huge number. Okay? Let's see if we can avoid that. So the first thing is, well, I know this side is going to simplify because the power rule tells me to multiply these, and 4/3 times 3 just gives me x to the 4th. Okay? And so what I'm going to do is I know I can write 81 as 3 to the 4th. Well, to the 3rd power, which means I can rewrite this as 3 to the 12th power. Okay? Now, what can I do now? Well, now I can take the 4th root of both sides. But again, if I take the 4th root of both sides, I gotta have that plus minus. So x equals plus or minus the 4th root of 3 to the 12th. Now, here's where I can rewrite this as an exponent, right? So I'm going to rewrite this as a rational exponent. So I can write this as x equals plus or minus 3 to the what? 12th power to the 1/4 power. And then of course, this becomes, well, this becomes 12 divided by 4, right? Which gives me plus or minus 3 to the 3rd, which again gives me plus or minus 27. Okay? Now, the thing here is you want to make sure you check both of these answers. You want to check positive 27 and negative 27 to make sure they both satisfy the equation, okay? And in this case, they both do. But double check to make sure because it won't always be the case, okay? So there's going to be cases, application type problems where one problem will be good and the other one won't. Okay, so again, but that's it. That's how we solve exponential equations. Okay? Have a great day.